Okay, so here is section 2.7 day 1, part 2 notes. Now that you have learned how a, h, and k affect our absolute value functions, we're going to use that to now graph certain absolute value functions. Now there are two ways of doing so. As you can see here, the first way is by making a table, like you've done before, okay, with linear functions, quadratics, exponentials, etc. Okay. So here we first have to identify our vertex. So to do that, remember our vertex is our h value and our k value. Okay. So if we look over at our function y equals 2 times the absolute value of x minus 2 plus 1, remember our h value is inside the absolute value signs and our k value is on the outside. So here, to identify our vertex, so we have our vertex. Remember, our h value is always the opposite of what we see. So in here, we have x minus 2. So when we write our value, it's actually going to be a positive 2. And then our k value stays exactly as we see it. So if we see a plus 1, then that means it's going to be a positive 1. So here our vertex is 2, 1. Okay, so let's go ahead. We're going to plot that. So we have over 1, 2, up 1. So that's our vertex right there. Now, in order to figure out the other points, we have to create our table. So we're going to create an x, y table. So when we do this, we are going to create 5 points. Now we have already found our first point, our vertex. So I'm going to put that in the middle because remember, our vertex is basically the point that is all by itself. Okay, it's the very lonely point. And really, the vertex is either going to be the highest point on the graph or it'll be the lowest point on the graph. Now here it says pick 2 values, meaning the x values less than the x value of your vertex. So we need numbers smaller than 2. So let's go ahead. We're going to pick numbers 1 and 0 because they're smaller than 2. Now we pick 2 values greater than the x value of your vertex. So let's go ahead. We'll pick 3 and 4 because they're a little bit bigger. Now what we do is we plug our values into our function. Okay, so the first one we plug in 0. When we do that, we have 0 minus 2. So I'll write this out here. So we have 0 minus 2. When we calculate that, remember, when you're taking the absolute value of a number, it does turn it positive. So the absolute value of negative 2, well, we'll make it positive 2. Now you multiply the 2 with the 2 that we got from our absolute value. That's 4. And then we add 1, we should get 5. So then you do it for when your x value is 1. So we plug it into there. So now we have 2 times the absolute value of 1 minus 2. So really all I'm doing is plugging my x values back into my original function for where I see x, like you've done before, okay? You've done these with quadratics, linear, and probably exponential. So now we do 1 minus 2 in the absolute value signs first. So we should get negative 1. Remember, anything in the absolute value signs, it makes it positive. So we get a positive 1. So we do 2 times 1 gives us 2, then plus 1 gives us 3. So we already know our vertex, which is 2, 1, so we don't have to worry about that. But now we're going to put in 3. So we have 2 times the absolute value of 3 minus 2, there we go, and then plus 1. Okay, absolute value signs, we do 3 minus 2. That gives us 1, and well, the absolute value of 1 is just 1. So now we do 2 times 1, that gives us 2 plus 1, and that'll give us 3. Now notice here that when I did our x value of 1 and x value 3, the y values were exactly the same. Remember, your y values are going to repeat around your vertex, okay? So the y values will repeat around your vertex. So really, in this case, we know these two are 3, right? So 0, our y value is 5. We can now assume that for 4, our y value is also going to be 5. So now all we're going to do is plug these x and y values onto our graph and then draw our line, and that'll be it. So now we have, let's do 0, 5. So 0, go up 1, 2, 3, 4, 5. Place your dot there. Then we have 1, 3. So go over 1, up 1, 2, 3. Then we have 3, 3. So we already did our vertex here, 2, 1. So we go over 1 more, 3. Then up 1, 2, 3. See how they have the exact same y values here? And then our last point, 4, 5. So we go over here and then up 5. And then all you got to do is connect your points. And remember, the shape that an absolute value function makes is a V, and it will always be a V. And notice that in this case, our graph is opening up. It's opening up because we don't have a negative sign in front of our A value. So we do not need to reflect. Okay. Now, that was our first way of graphing absolute value functions. Now, using the exact same function, I'm going to show you a second way. So I'm going to rewrite our function so we remember what it is. So y equals 2 times x minus 2 plus 1. Now, the second way is, well, once again, using transformations. Okay. So once again, we have to identify a vertex. You should always identify your vertex. It makes it a lot easier to graph your function. Now, we already said that our vertex was 2, 1, and we're using the exact same function as above. So we just basically rewrite that, so it's 2, 1. Now, we need to plot that on the graph. So there we go. Now, here, what we need to do is identify A. In this case, A is the slope of our right side. Okay, so we're going to use our slope to plot the points. So remember, A is the value in front of the absolute value signs, so our A value is 2. So using rise over run, remember slope is rise over run, we go from our vertex, and in this case, our slope is going to be 2 over 1. So we go up 1, 2 over 1. Plot your point. Up 1, 2 over 1. Plot your point. Up 1, 2 over 1. Up 1, 2 over 1. There we go. Now, remember, our shape of the absolute value is a V shape. So on the other side, we're going to have similar Y values. So what we do next is we go to the left side, meaning we go back from our vertex. We're going to go up 2 because that's our slope. But now we go to the left one. And we do the same thing. We go up 2 and then left 1. Up 2, left 1. Up 2, left 1. So every single time you're plotting using your A value or your slope, you will always go up or down with what your slope is and go to the left and to the right. So then we just connect the points. Make sure you have arrows at the end of your graph because this goes on forever. And once again, our graph is opening up because we have a positive A value. Okay, so those are two ways. Now, when you do your homework or you do this on a test or quiz, I do not care which one you do. I would just say use the one that you think is the easiest to use. So you can either graph the functions by a table or graph using the transformations. Okay, so our second set here of notes is we're going to do the exact same thing as we did before. We're going to state the vertex and graph it. But now what we have to do is write the transformations. Basically, you're going to compare each of your functions to the parent function. So remember, the parent function is y equals the absolute value of x. So this is where we're going to use our A, H, and K values to list what is happening to our function. So this is our parent function. Okay, so I'm going to do the first one with you. So we're going to do A together, and then B I'm going to have you do on your own. So I know number 2 says list the vertex, but you really should do that first, okay? So we're going to list the vertex of A. So here we have the absolute value of x plus 2 minus 3. Remember, your vertex is your H, comma, K. So remember, our H value is always the number inside the absolute value signs. Your K is on the outside. If you don't remember this, one thing I say is, well, H is a letter that comes before K. So your H value will always come before K. So that's maybe something you can use to help yourself remember that. Now remember, for an H value, it's always the opposite of what we see. So in this case, we see x plus 2. Well, the opposite of a plus 2 or a positive 2 would be a negative 2. So we write negative 2. And then K is exactly what you see. So since we see a negative 3 or a minus 3, it's just like that. There we go. Now for A and B, I'm going to use the method of the slope. Okay, so first graphing my vertex and then figuring out my A value and then using the slope to plot the other points. If you want to use the table, you can do that as well and see if we get the same exact answer. So I need to plot negative 2, negative 3, so I go over to the left 2 and then down 1, 2, 3 and plot my point. So now in order to plot the other points, I have to find my A value. Remember, A tells you the slope. Now here you don't see a number in front of the absolute value signs. When that happens, that just means we actually have an assumed 1. It's like if you had x. Well, we don't write 1x because the 1 is assumed. It's the same thing here. So our A value is just 1. So that's going to be our slope. So now going here, we can tell, right, we don't have a negative sign in front of our A value. So you can already tell if we don't have a negative, this should be opening up. And that means that our rise is going to go up instead of down. So going from my vertex, I'm going to go up 1 and then to the right 1, up 1 to the right 1. And then I just kind of keep going on. Then you do the exact same thing. You go with your vertex, still go up 1, but now you got to go to the left 1. And then you do that for a few points as well. Once you've done that, you're going to connect your points. And then we have that. Good. Now, our last part is we got to compare the graph with the graph of y equals absolute value of x. This just means we have to list all the transformations. So you should always ask yourself first, do we reflect? Remember, reflecting means that instead of having it opening up, we're going to have it opening down. Well, we see here that our graph is already opening up. So we already know that, well, there is no reflection. Okay, so if there's no reflection, you don't need to write anything for that. Okay, so now let's talk about if we have what is called a vertical stretch or shrink. Remember, a vertical stretch means that the absolute value of A is greater than 1. So that's what we would call a vertical. I'll just put vert for short, and it'll be a vertical stretch. Okay. So that's when your graph is getting more narrow. Now, if your A value or the absolute value of A is less than 1, so that really just means like 1/2, 1/3, 2/5, anything like that, we would call that a vertical shrink. Okay. Now, in this case, if your A value is exactly 1, that means you're not really either stretching your graph or shrinking it at all. It just means that it has the same line as the parent. So we look here, we saw that our A value is 1. Well, for the parent function, the A value is also 1. Okay? So for your parent function, the A value is also 1. So that means we don't have a vertical shrink, neither a vertical shrink. Okay, so we don't need to write anything for that. So our last thing is our translations. Okay, so here we're going to write how much do we translate. So that means we're going to either go to the right or to the left, or up and down. So we look at our H here, right? We see that we actually go to the left too. So here we're going to write, we translate left 2 and then we have to see if we either go up or down or neither. Well, here it looks like, right, we go down 3. So that means we translate left 2 and then down 3. There you go. Now, some other vocabulary you might see is a horizontal shift. Basically, remember horizontal means side to side. So left 2 can also mean maybe a horizontal shift of 2. So you can also write that. So I'll kind of put that in parentheses so you know there's different ways of writing this. So you can translate left 2, or you can just say this is a horizontal shift of 2. And really that would just mean the exact same thing. So horizontal shift of 2. And then you would say down 3. Or another way of saying this is a vertical shift. So vertical, remember, it goes up or down. So since we're going down, we would just say a vertical shift of 3. And that's another way of writing it. I am okay with either or of how you write it. Just make sure you use either or. So make sure if you use translate, you do that throughout, or you can use horizontal shift and then vertical shift of 3. So really, there was only 2 transformations. It was just a horizontal shift and a vertical shift. So what I would like you to do is now try example B. So I want you to pause this video, and I would like you to state the vertex, do that first, then graph the function, and then compare the graph of B with the parent function. So listing all the transformations. So go ahead and pause this video. Okay, so hopefully you paused the video. I'm now going to go over this problem. So remember, the first thing we should always do is state the vertex. So we want your h and k. In this case, remember, h is inside the absolute value signs, k is outside. H is opposite of what we see, so we see x minus 1. So the opposite of minus or negative 1 is a positive. And k is exactly as we see it. So we see a positive 2 or a plus 2. That means we just have a positive. So now, once again, as I said before, I'm going to use the method of figuring out what the a value is and then using slope to graph it. So I'm going to go 1 up 2, and now I have to figure out what my a value is. Remember, the a value is always the number in front of your absolute value signs. So here we have our a value is going to be -4 because we have that negative. Okay. So because we have that negative, that means we are going to go down when we're doing our slope. So we go from our vertex, and now we go down for 1, 2, 3, 4, and then we go to the right 1. Because our slope is really -4 over 1. Okay, do it again. 1, 2, 3, 4. So we go down 1, 2, 3. There we go. 4, then over 1. And you keep doing it. 1, 2, 3, 4, and then over 1. There we go. So now you do the same thing. You go down 1 again, or go down 4. 1, 2, 3, 4. But now go to the left 1. 1, 2, 3, 4 to the left 1, and then 1, 2, 3, 4 to the left 1. Remember, you're always going to both the left and right side, because this is the absolute value makes a V shape. There we go. Okay, so now that we've done the first 2 parts, now we have to write our transformations. So here, let's list our first one. So now we have to see if we flipped our function, meaning is our function facing down? Well, as we can see, it is. So that means we had what is called a reflection. Now make sure if you ever have a reflection, write that first, okay? Because really when you reflect, you could reflect it over any line on the graph. But it's just a lot easier if you just say reflection, and then make sure you say over the x-axis. It's very important that you say specifically the x-axis, because you could reflect it over the y-axis as well. But we won't deal with that for this lesson. So make sure whenever you have a reflection, write that first. Because if you don't, then technically it will be incorrect. So we have a reflection over the x-axis. Make sure you write the x-axis. Now we have to see if we have a vertical shrink or stretch. Well, our a value is a number other than 1. And here, remember, we want to take the absolute value of a to see if it's greater than or less than 1. So if we take the absolute value of a, which is this case -4, right? Remember, absolute value of any negatives, make it positive. So we actually do get 4 as our value, which that is greater than 1. So because it's greater than 1, this is a vertical stretch. So we write a vertical stretch. And then make sure you write what the factor is. So we say vertical stretch. And then you say a 4. Now we're not doing -4 because really the negative just tells us if our graph reflects or not. Really we're just stretching by 4. That's it. Okay, so we have a vertical stretch of 4. Now we have to see if we translate it. So here, if we look in our H, it looks like that we translate it to the right one. So here I'm going to write translate. Right one. Now, if you don't want to use the word translate, you could say horizontal shift. Remember, horizontal means side to side, so you did a horizontal shift of 1. That's another way of writing it. And then let's see if we move up or down. So we translate right 1, and then we translate up 2. So I'm going to say up 2. Another way of writing this is would say a vertical shift of 2. So you could say that as well. And basically that is all our transformations. So make sure that you write all of them, because if you're missing one, I will count that off on the homework. Okay? Now remember, if you have any questions on this, email me. You can always come in before or after school. That's another good option. And then here will be the homework. Now, the next day in class, we will be working on this, writing transformations and all that stuff. And then you'll have plenty of time to work on your homework. And so your homework actually won't be due on Friday, until Friday.